right, in this video, our goal is to identify the center, the vertices, and the foci of an ellipse given the equation in standard form. So let's first and foremost identify if it is a horizontal or vertically represented ellipse. Well, because the number under the y squared term is larger than under the x squared term, it is going to be a vertically represented ellipse. It's a vertically represented ellipse. So what that tells me is that a squared is equal to 49 and that b squared is equal to 9. And again, what we are referring to is that we have x minus h squared plus y minus k squared over a squared over b squared is set equal to 1. And again, the a is underneath the y squared because that means it's going to be on the major axis vertically for our major axis there. And again, the reason why I know that is because the larger number is underneath the y squared term. All right, so we know our center, in this case, is going to be at 5, -2. Here's our, oh, I'm sorry, I turned in the wrong order there. At -2, +5, because here we have h and here we have k. And then we want to find out where the vertices are going to be. Well, I like drawing these out. I think it really helps visualize what we're looking at. So our center is at -2, 1, 2, and 1, 2, 3, 4, 5. So that means that since my a squared is 49, a is 7, and b is 3. So what this tells me is that I have a distance above the center of 7 and a distance below the center of 7. So 7 above 5 is going to put me up here at -2, 12. And then 7 below is going to put me down here at -2, -2. So that means the two vertices are going to be at -2, 12 and at -2, -2. All right, and then the last thing it wants us to find is the focus points, all right, or the foci. Well, if you see this B here, this B helps us identify where it's going left and right from the center. And so that means I am 3 units to the right and 3 units to the left, putting me at 1, 5, and putting me at -5, 5 for the minor axis endpoints. Well, what's true about our ellipse is that our Pythagorean identity says that using this A, this B, and then C representing the distance from center to the focus points, focus point, I can say that a squared equals b squared plus c squared. Well, a squared was 49, b squared was 9, and we want to find out what c squared is. So c squared equals 40, square root both sides. You get c is going to end up equaling plus or minus, now I'm going to go ahead and simplify this radical, of 2 square root of 10. All right, so at this point, what does this really tell us? Well, what this tells us is that since it's a vertically represented ellipse, I am 2 square root 10 units above my center at -2, 5, and then I am 2 square root 10 units below -2, 5 for my center. So that means my focus points are going to be found at -2, 5 plus 2 square root of 10 and at -2, 5 minus 2 square root of 10. Now, depending on what you're doing with it, maybe you will leave it just like this, this is exact, right? This is an exact form. But if it says round to the nearest anything, then you might want to get some approximations in there. So just approximately, this comes out to be -2, and then about 11.32, and then approximately -2, and roughly -1.32 there, rounded to the nearest hundredth. And so we have our center, we have our vertices, and we have our focus points.